If you build an IntelliJ Platform plugin and your plugin throws an exception, the IDE will show an error dialog. But that does not mean your users can send the information about the error to you. Let me show you. Here is an IDE with the key promoter X, one of my plugins installed, and I did not set up error reporting. Now, let's trigger a fake plugin error. The IDE detects that it belongs to my plugin. The error UI appears, but right now, the report button is grayed out. So if your plugin has no error reporter registered, your users can see that something failed, but they cannot send it. And you, as the plugin developer, you don't get any useful report. Yet. Because we're going to learn how to set up error reporting for your plugin, from a 1-minute setup to a fully customized solution. The reason error reporting is useful is that I do not only want to know that something failed. I want the user's comment, the stack trace, any attachment they chose to include, and enough plugin context to see where the problem came from. Because that changes the situation for me as a developer. Instead of a vague complaint, I get detailed information I can use to debug the problem. Let's get started. To enable error reporting in your plugin, you need to register the error handler extension point with an implementation that extends the abstract class ErrorReportSubmitter. At that point, you have two practical options. The first option is the ready-to-use JetBrains Marketplace error reporter. So, when your plugin is published on the JetBrains Marketplace, enabling error reporting is just one line of code. The second option is a custom implementation of ErrorReportSubmitter. This makes sense when you want to send your report to services like Sentry, Rollbar, or GitHub. Or when you need control over the report format, the privacy text, or the user's experience. Both options use the same error handler extension point. So the question is simple. Is the built-in marketplace flow enough, or do you want to control the submission yourself? Okay, let's go back to the Key Promoter X plugin and look at how to enable the marketplace reporter. In my plugin XML file, I register a new error handler extension point and chose JetBrains Marketplace ErrorReportSubmitter as the implementation. That's it. We're already done. Now, after rebuilding the plugin and triggering the same plugin error again, the report button in the error dialog can be clicked. And if you do that, the error report will show up on the marketplace page for your plugin. There, you can find all the reports, stack traces, and metadata about the error. So if this simple setup gives you what you need, start here before you build something custom. Which brings us to the next point. What if you need something custom because you want to use a specific backend or because you want to control the extra data that goes into the report? The custom version is also not a large framework. You register an error handler, implement ErrorReportSubmitter, and IntelliJ sends the plugin error reports to your submitter. Your submitter can provide the report button text, it should provide the privacy text, and when the user sends the report, IntelliJ calls your submit method. To show you exactly how this works, I use a small demo plugin, and I'll link the GitHub repository in the description of the video. At the center of the demo is the ErrorReportSubmitter base class that extends ErrorReportSubmitter. Here, submit is the method IntelliJ calls after the user decided to send the report. My job here is not to do all the work directly. My job is to take the IDE data, start the real submission work in the background, and return quickly. To do that, I first built an error report data object. This is my own report model with everything I want to send over the backend. The interesting part is build from event. This is where I take the idea logging event from IntelliJ and extract the pieces I actually care about. The stack trace comes from the event. Attachments come from the event. And then I add extra metadata like plugin, IDE, OS, and Java information. Once I have the data, I hand it to Error Report Backend. It gives me a clean place where I can swap in different backends without changing the IntelliJ facing code. For this demo, This is completely overkill, and most likely you won't need it in your own plugin, but it shows the separation of concerns. Note that submit returns true instantly, which indicates that sending the report has started in the background. The real return value from the backend is a report submission result. That is a small result model between transport code and IDE integration. I only need 3 outcomes here. A new issue was created, a duplicate was found, or the submission failed. After that, handle submission result converts the backend result back into IntelliJ's own format. IntelliJ wants a submit report info, so this is where I convert my internal result into the status the IDE understands. This is also where I show the follow-up notification for the user. The backend work itself runs in error reporting coroutine scope. I keep that in a service so report submission run in a dedicated coroutine scope and stay off the UI thread. That matters because submit is part of the user reporting flow, and if your submitter does networking work, JSON processing, file work, or any other expensive work directly on the event dispatch thread, the report UI can freeze. If anything goes wrong while sending the report, handle submission report handles it. This is where I turn exceptions into a clean failed result and the right user-facing message. And finally, there's new build available exception. That one is just a special case. It lets the backend say, I did not file this report because there's already a newer plugin build available with a fix. For this demo, I implemented only one backend that does nothing more than show what would be sent in a dialog window. If you look at Display ErrorReportSubmitter, you'll see that it only builds a text version of the report data and shows it in a dialog wrapper. In your plugin, this is where you would use the API of your report service to send the data. That could be Sentry, Rollbar, or any other service you like. Now, these are already the most important things you need to know about the public API, but I also wanted to see what JetBrains' own reporter sends. So I built a small wrapper around JetBrains' internal reporter and redirected it to a local fake server. To be clear, this class is only for inspecting the request and understanding the kind of information JetBrains include. It uses reflection and it should never see any production environment. The scripts directory contains a local Python server. After starting it and registering testjb error reporter local server as error handler in your plugin XML, I can trigger the same plugin error and look at the request that arrives in the terminal. Now I can compare what the JetBrains reporter sends and decide what information I want to have in my custom report model. However, especially the private user data is not accessible to third-party plugin developers. The important lesson here is not just to copy what JetBrains does. The useful lesson is that the same things show up. What failed? Where does it fail? Which plugin was involved? What environment the user had? What the user wrote? And which attachment came with the report? So I would keep the useful things in my own plugin and ignore the details that only make sense for JetBrains. Freeze reports are a good example of why attachments matter. For normal exception, a stack trace and user comment may already help a lot. However, when your plugin freezes the IDE, you may also need dump files and other freeze-specific artifacts. Those files can explain what the IDE was doing when the UI stopped responding. That is especially useful for threading problems. Okay, let's summarize. If your plugin is on the marketplace and the built-in reporter gives you what you need, use that first. It's the smallest and most direct option, and soon the marketplace will provide freeze attachments as well. Many plugin developers will find marketplace error reporting completely sufficient. If you need control over the backend, the report format, the privacy text, the user experience, or how reports are processed, implement a custom error report submitter. IntelliJ already gives you a clear place to connect your error reporting. Before we finish, let me add one more detail. There is another API called ErrorReportSync, and it's important not to confuse it with ErrorReportSubmitter we discussed here. Error Report Sync is for automatic background reporting. ErrorReportSubmitter is for user-facing error reporting. I already covered Error Report Sync in another video, and I'll link it in the description. Additionally, if you want information about a Sentry-based error reporter, Joachim Ansorg wrote an excellent blog post about it. I'll also link this one in the description. If this helped, please like the video or comment which topic we should cover next. See you next time.